has a cathode and an anode, and what they've done is they've taken some gas inside this tube, and because they have this anode and cathode, they obviously have connected it to some potential difference, right? Some battery or some high potential difference. So over here they've taken it as high potential of 10,000 volts. And what they've done is that they varied the pressure. So at high pressure, nothing happened. But when the pressure was reduced to 0.01 mm of, so when the pressure is reduced to 0.01 millimeters of mercury, it is reduced to that level, then we start to notice that there is this green light that is passing through the Crookes tube. So what is this green light? Okay, so this green light is called cathode ray. Okay, so a bunch of these green lights together is called cathode rays. And the direction of the cathode ray, it starts from the cathode and goes towards the anode. Because the cathode rays start from the cathode, they are called cathode rays. Okay, so so you can see in this picture the green colored ray is called the cathode ray, and you also saw in the demonstration that he was taking a magnet and he was going over that tube, and you could see that this ray was deflecting. So if this ray is deflecting, that means what? What does this ray have? If it is being deflected, it should have a charged particle, right? So when you put a magnet close to that, it is being deflected. That means that there should be some charged particle. Okay, so that is how electrons were discovered. Okay, by cathode ray experiment, electrons were discovered, and in 1897, J.J. Thomson measured the mass and charge of these particles, which were named as electrons. So in the right hand side of the picture, you see a paddle. Do you guys know what a paddle is? Okay, yes, okay, that's a pedal, but quite close. No, that is P-E-D-A-L, pedal, okay? So it's a pedal of a bicycle and paddle. Pedal and paddle are two separate things. So pedal belongs to the bicycle that you all know. Paddle is, for example, in boats, they have a paddle with which you can change the direction in which you're going, right? In boats. But yeah, so it is inside, so it's there on the bottom of, boats and ships. So basically what it does is it helps change the direction of the boat. Similarly, paddles are there even in planes. So in planes also they do the same thing. They help changing the direction in which the plane is going. Paddles are there even in your fans, right? So your fans, if you look at the blades of the fans, those are also called paddles, okay? So the blades, also your fan is also paddle. If you look at windmills, right? Windmills also have paddles. So similarly, if you look inside this tube on the right hand side, you will see a four fan-like thing, okay? You will see like a fan-like thing with 4 blades. Do you guys see that?
Yes, ma'am.
Yeah, so that is a paddle, okay? All right, so what happens is when these cathode rays are passed, you see this green color light. But then they were like, okay, so the cathode rays are passing through the tube. When I see a green color light, let's put a magnet and this thing is shifting. But if you notice that when he put the laser light and he put a magnet, that laser light was not deflecting. That only this green light, only the cathode rays were deflecting because of the magnet, but the laser light was not being deflected by the magnet. That means that cathode rays have something that the laser light does not have. Laser light is just a light, it does not have any particles, whereas the cathode rays has some particles. So in order to prove that, what did they do? They put it inside the tube on the right hand side. So what happens when these particles hits those blades of the pedals? What happens? No, when I put a magnet, it gets deflected. When I put a magnet near the cathode rays, the cathode ray gets deflected. You saw that in the video. But when I pass these cathode rays in that the tube on the right hand side, and those cathode rays, they have charged particles, right? When those charged particles hit the blade, then what happens to the paddle? Yes, it will move. Yes. So the paddle will start rotating. It will start moving because when a particle hits it, it starts rotating. Okay. So that's how you know that, okay, these rays is not just light. These rays are light as well as particles. Whereas laser light has no particles. It is just light. Okay. And this one, it has some particle in it, which is why it's moving. Okay. So that is what they noticed. So yeah, so J.J. Thomson found out what electrons is. He found out the mass and charge of the particles, and he called them as electrons. All right, so what are the properties of cathode rays? So cathode rays travel in straight lines. They contain some material particles. These material particles are negatively charged and they are affected by electric field. They are also affected by magnetic field. We saw that in the video. He takes a piece of magnet and we notice that the green lines have deviated. They're no more in straight line. Okay, when you put a magnet. When you take off the magnet, again it travels in a straight line. Anyway, so cathode rays generate heating effect. Cathode rays affect zinc sulfide screen. Cathode rays ionize gases. So do you guys know what is the meaning of ionize? Charging, yes. So how do these cathode rays ionize gases? So I'll tell you what happens is when these cathode rays are moving through the tube, right? When they're moving through the tube, there is limited amount of gas inside the tube, and the pressure is very, very low. So because the pressure is low, the number of air molecules or the number of molecules of gas within the tube are few. And when these electrons, which are present in the cathode rays, when they move, when they're going at high speed, okay, and when they go at these high speed, they hit the molecules of the gas. And when they hit the molecules of the gas, what do? They take some more electrons from those gases, they take electrons with them and they go towards the anode. Okay. Now, because they have taken away these electrons by hitting with cathode rays, they're hitting the molecule, and when they hit the molecule, they take away the electrons from those molecules, and because those molecules have lost electrons, those molecules become positively charged. And when a molecule is positively charged, what happens? It becomes an ion, a positively charged ion. So that is how cathode rays ionize gases. Okay. So cathode rays have penetrating power, meaning they can penetrate through a molecule and pull out another electron, or they have the penetrating power. Cathode rays produce X-rays, which is why if you notice X-rays are green in color, and X-rays also penetrate through our bodies, and that is how we can, like, not through our bones, which is why we can get an image of our bones by passing X-rays through us. We can get pictures of our bones. So the E by M ratio of cathode ray particle is constant. So what is E by M ratio? It is charge to mass. Okay, E by M means charge to mass. E is the charge of an electron and mass is mass of an electron. So E by M ratio of a cathode ray particle is always constant. It does not depend on anything else. So we'll calculate what that E by M ratio is. Okay, so we have another video. Hopefully you guys are able to watch it. If you're not able to watch it, then all right. So what is happening is, do you guys know what an atomizer is? So basically that is an atomizer. What this does is it takes the liquid that is present inside this bottle and it breaks it into tiny, tiny particles and it sprays it on you. So it's not the size of an atom, but it's very, very tiny. So we call it an atomizer. Okay. So that is what an atomizer is. Basically it's a spray. Okay. So this atomizer, it contains some oil, and then you press into this, and then the oil particles come out as a spray. So these small oil droplets, they come on top of this charged plate, and that charged plate has a small hole. Okay. So the oil droplets are on top of that charged plate. It has a small hole, and then what happens is the oil droplets go down. Okay, they go in from that hole down. Okay, and when they're going down, they take the charged particle. They take an electron with them. Okay, and there is a viewing microscope where you can see what is happening inside. That is what the experiment shows, the video shows. So if you guys want, you can go back and see the video now that you understand what an atomizer is. So the oil that goes in from that small hole, it picks up the charge. Okay, so the charge is there and the oil engulfs the charge, and the charge comes into the oil. Okay, and then it becomes heavier and then it goes down. And when it goes down, it measures, so the oil droplets are under observation and it measures the weight of this oil particles, and that is how you measure the weight and the charge of the electrons. Does that make sense to everybody? The charge of the electrons is measured by, you have like a measuring instrument on the left hand side. It shows you positive and negative charge, and that will tell you what is the charge of the electron. That is what that video is explaining, nothing else. Okay, so yeah, anyway, so electron has a unit negative charge on it. That means what you see over here, right? Minus 1.6022 into 10 to the power minus 19 coulombs. That is taken as a unit charge. That means minus 1. So electron has a unit charge of minus 1. Its mass is 1 by 1,837 times the mass of an hydrogen atom. And hence, because it is so small compared to the hydrogen atom, and hydrogen atom itself is it's very lightweight, and because it is so much more lighter than a hydrogen atom, we'll consider it as 0. Okay, for all our calculation purposes, we'll consider mass as 0. So therefore, it is denoted by the symbol E superpower 0 and subscript minus 1. Okay, so that is how an electron is represented. E superpower 0, 0 meaning it has no mass, and minus 1 meaning it has a unit charge of minus 1. Okay, so if somebody asks you what is the charge of an electron, you will say minus 1.022 into 10 to the power minus 19 coulomb. Coulomb is the SI unit of charge. Okay, if somebody asks you what is the unit charge of an electron, you will say minus 1. Unit means what? Unit means 1. Okay, unit charge means a single charge, 1. So unit charge of an electron is minus 1. Charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. Okay, all right. So can we calculate? Let's calculate this. The specific charge is defined as the ratio of charge to mass of a particle. Find the E by M ratio of an electron. So mass is given to you, charge is given to you. We need to find out the E by M ratio. So I told you E by M ratio is the charge of the electron divided by the mass of the electron. So can you guys calculate and tell me what your answer is? Yeah, Bhumika, it is coulomb per gram. You are right. Also, whenever you mention gram, don't say GM, just say G, okay? So C by G. All right, yeah. So I was saying that one of you got 8 and the other got minus 8. So just check who is right.